In this part of our series, we're going to focus exclusively on the design and design issues rather than statistics. And then we'll start working on statistical analysis of data obtained from these designs in the next part. Remember that the overarching topic here of Within Subjects Designs was entitled Repeated Measures and Randomized Block Designs. And what we saw in recent videos is that we had a simplified version of that even in our first statistics course. Repeated measures was pre-post and randomized block was matched pair. The common thread of those two designs is that we only have two measures, pre-post or matching on a pair, control treatment or treatment A, treatment B, anything that can be paired. What we're going to be doing now is we're going to be extending that. We're going to be generalizing what we learned back in the first stats course to have more measurements or more conditions that we're matching. So as a first step in this, let's identify two types of factors that we see when we design experiments or observational studies. I've actually mentioned both of these types of factors, but now let's formally define it. When each individual is measured at only one level of a factor, the factor is known as a between subjects factor. If you think back to the work that you have been doing the last few weeks, when we looked at one factor analysis of variance, you were comparing counseling conditions. Every member of that study was in one and only one counseling condition. That is, each participant was only at one level of a factor. So there were, if I recall, 4 or 5 different counseling conditions, counting the wait list and the traditional treatment. And when we looked at the participants in that study, each of them was only at one of those levels of that factor. That is, only one of those conditions. So that was a between subjects factor. When we looked at the two-factor design, both of those factors were between subjects factors. We had organized and disorganized lecture as one factor, and the other factor was type of note-taking, outline, linear, or matrix. Every individual was either in an organized or disorganized lecture, and every individual was in either outline, linear, or matrix notes. They were not in both kinds of lectures, and they were not taking more than one type of note or using more than one type of note. So all the factors that we have looked at before this series of videos focused on between subjects factors. When we started this series of videos, I began by introducing pre-post, and I told you the explanatory variable was time. Time had two levels, before and after, and participants were in both levels. This is a within subject factor. When each individual is measured at all the levels of a factor, the factor is known as a within subjects factor. Now, this may seem like a pretty straightforward, simple idea, but it's one that you need to ingrain into your thinking when you're going to analyze data, because you have to be aware of which factors have levels that each participant is only in one level, or which factors have levels in which participants are in more than one level. And the reason we have to know that is because it changes quite a bit how we analyze the data. Remember that one of the conditions for valid inference for between subjects factors is that individuals are independent of each other across the different conditions. Obviously, with within subject factors, they are not independent of each other. They may even be the same person in multiple conditions, such as what we saw when we looked in the last part of this series at the thread data and participants doing both left and right threaded timings. So get used to identifying not only what are the factors, how many factors are there, but also identifying whether you're looking at a between subjects or a within subjects factor. Now, when we analyze the effects of a factor, which of course is the meat of any experimental study, to see how much levels of factors differ from one another, and therefore how much of an effect there is. For instance, if you have a control treatment, how effective is the treatment depends upon how it compares to the control. So analyzing effects is right at the heart of the study, and here's what we're going to do. What we've already done with between subjects effects is we compared the variance between groups to the variance within groups to see if the variance between groups went above and beyond the variance within groups. So let's call this up here and give ourselves some reminders. So when we looked at our F ratio for between subject factors, we looked at the mean square for the condition or the groups, divided it by the mean square residual, which is the variation within groups, with the idea being that if there is an effect of conditions, if these conditions differ from one another, that mean square groups is going to be bigger than mean square residual, and your F statistic will be bigger than 1. If there is no difference in groups, we expect the mean square for groups to be about the same as mean square residual, and so you're going to have an F ratio near 1. Okay, so that's what we mean when we talk about estimating by comparing variance between groups to variance within groups. Now let's consider analyzing effects for within subjects. This one's going to take a little bit of explaining. Within subjects effects can be estimated after removing the variance that is due to individuals and then comparing variance between levels to the remaining variance. Okay, so let me look back at this. So this was what we had for between subjects. So we have the variation of our conditions from one another, and then we have the variation within conditions. Well, what is the variation within conditions? That variation within conditions is just the variation of individuals. For instance, in the counseling, one method of counseling might do a better job of reducing PTSD on average, but you still have your counselees are going to vary about that average. And that's the variation that is our residual here. But if you have a within subjects design, like when we had the thread experiment, the threaded left and right hand threads that we were trying to move as quickly as possible, what do we have? Well, we still have the mean square for the different groups or conditions, the left and the right thread. Those would be the two conditions. And we still have the variation within each condition, except think about this variation within each condition for a moment. It's the same people in both conditions. So let's suppose that you and I both participated in this experiment, and your on average 10 seconds more than me. Okay? Well, you're going to be faster than me with the left thread. You're going to be faster than me with the right thread. But I doubt you're going to be 10 seconds faster than me with both left and right. That's sort of on average you're faster than me. But the fact that we're in both conditions means that we're creating variation. We, the same people, you and I, are creating variation within both the left thread conditions and the right thread conditions. So we can break this down a little bit so that this is the mean square between the groups, the conditions, which are left and right thread, and the mean square residual is created by the mean square due to different individuals. I'll just put here people, okay, plus something else. That is, we have variation because some of us are faster than others at this task. However, we're not always the same amount faster for left as right thread, so there's some other leftover component of variation. This other part, let me just call that. This is the other part. Yeah, come on, Mike. Okay. So this is, this variation due to people cuts across all conditions. So you might be on average 10 seconds faster than me. But it doesn't tell us what's going to happen within each condition. The fact that you're on average 10 seconds faster, you might be 12 seconds faster with right-handed threads and 8 seconds faster with left-handed threads. So there's a variation that we can't explain. So there's a variation that's due to our explanation being that we're different people, but then there's this other piece that we can't really explain. So what we do within subjects designs is we measure this variation between people and we take it out. So here's really what we end up doing within subjects designs. We take the mean square due to conditions, that is how conditions are different from one another, and we divide it by the mean square of this other after taking people out, after removing the variation due to people. And that's how we do within subjects. Well, what's that going to do? If I take out this mean square, if in this mean square residual here that has people and then something else, if I take out the people, that's going to reduce the residual. And if we reduce the residual, if this residual down here is just due to other after removing variation due to people, it's a smaller number, which means that the F is a bigger number, which means that we have more power or more ability to detect when there are differences in conditions. So this can lead to it being a very powerful design. So again, within subjects effects can be estimated after removing the variance that is due to individuals and then comparing variance between levels to the remaining variance. We can only do that, however, if we actually have the same individuals across all conditions, which isn't always possible because of multiple treatment interference, or if we have matched up individuals. Rather than using the same individual in each condition, we match and then use individuals. So we'll talk more about that as we talk about repeated measures and randomized blocks design in the next part.